Hello friends, welcome back to SuperOffice channel. In this video series we are working on the Marklin Toporama Z-scale layout. This is the fifth part in the video series. There are already 4 different parts which is already uploaded, which you can watch in series. In the fourth part we discussed about the layout table design and its compactness, and also its utility of having a small hatch inside where it can include all the components, which can be the entire table layout also can be like moved, opened and closed, that kind of arrangement. So all this we discuss in the design aspect of the table, and followed by that we also discuss about what are the electronic components that go into it to achieve the smart layout control system that we are hoping to achieve. So in this video we are going to see how this entire smart layout system is implemented. I have completed the wiring and connections, and I have also tested the program logic also. So this in this video we are going to see how each of these elements are installed into this control system, into this hatch. Next, what are the power consideration for this layout, because since it's got multiple inputs, we will be needing different multiple power sources. So but ultimately we want to achieve what is called as a single input power socket. Means the wall socket will have only one plug which goes into the wall socket, and the rest of the entire layout is controlled using that power that is received from that. How we are going to achieve that is what we are going to discuss as a second part. And the next is how this entire wireless control system is controlled using a small iPad or a tab or a smartphone or a computer laptop. How we are going to implement that along with the components and the wiring details and also the program logic. All this we'll discuss. Finally, on the fourth part, we'll be showing a small demo on how the wireless control system also works. Okay, this is the bakelite sheet, or what we call it as a hilum sheet in our Indian terms. Actually, this is a laminate sheet, and it is generally used for making the switchboards and other electrical control boxes in India. I have taken a 1.5 by 1 feet length sheet, which is the maximum size available, and this sheet I have cut various sections like this here and here to assemble the microcontroller, the motor controller and other relays boards and all. And these holes are drilled according to that board's mounting positions, and we will now continue to see how we want to quickly assemble these things into this board. Okay, the next part that we are going to install is the motor control for the Magno rail system. So this comes with this kind of connection, the 2 wires for the motors and 2 wires for the power, and there is a speed controller, potentiometer and a reset switch also. So we are going to mount this motor controller onto the board along with the speed controller. Now we will get to see this now. Next, we will connect this DB25 breakout board, and this will connect in turn to the LPT1 port, which will be coming from the layout. Okay, now the control board is ready. The mounting for the microcontroller. On top of that, the Wi-Fi controller also will get mounted using a screw. And these are the relay channels and the DB25 breakout and the motor control. So only wiring is remaining. We need to connect it to the main board. I may not be able to show the wiring video completely, but I will try to share the wiring diagram, so that will be of more helpful to you. There will be another video also on the power section, which is also very interesting. We will see. Okay, to start with the power considerations for the layout, we will go one by one. First is this, for running the locos on the layout, initially I mentioned that we will be using NC power cap DCC system. It comes along with the power adapter, which is this power adapter is having a rating of 13.8 volts at about 1.5 amps, which can run up to 4 N scale locos. This is one adapter that you need. Next is we will also be needing for the motors, which is a part of the layout for the moving car system. So for that you will be needing a 12 volt DC adapter, a separate 12 volt DC adapter like this, which is rated at about either 2 amps or 1 amps. So you will be needing this second adapter for running the moving car system. Third is basically the layout control system. The Arduino and the relays and the sensors, they all operate at 5 voltage. So for that you will be needing a separate 5 volt DC power supply using a USB cable. Through an USB cable you need to run it. So separate 5 volt supply with any mobile phone adapter or any 5 volt USB adapter is required for this. So that's a third power supply unit that you need. And also you will be needing a separate power supply to run your signals, basically your semaphore signals, and also your switch turnouts. All these solenoids, they all need 11 volt AC supply. So 11 volt AC supply is the fourth supply that you need for this. And also you will be decorating the layout with the street lamps, building lights and all those things. For those, generally owing to the size of the Z scale layout, we will be using SMD LEDs. Generally SMD LED voltage requirements is around 3.3 volts. So for that again you need a separate power source. Well, if you see, like, nearly you need about 6 different varieties of power source for the single layout. And my objective is to remove multiple sockets, each and every AC sockets which is there for each and every power source. I wanted to remove and have a unified single power socket. While I was thinking for that solution, first thing that came up to my mind is an SMPS power box. I could get a decent 12 volt 5 amp or a 10 amp SMPS and install it in the base of the layout and start providing the sources by converting the output voltage to the desired output that is required for various circuits. Okay, so another thought came across my mind. I thought I could make use of that idea. So what I thought is basically I could make use of the SMPS power box that comes in a CPU or a PC cabinet, one like this. Basically, if you see here, this is a very versatile SMPS supply. The good thing about is that it has got a very decent rating. Main cause of worry for me in the previous different set of sources of supply is that each one had a own power rating, and especially the 3.3 volt and the 5 volt drive did not have much amperage, like it was not exceeding 1 amp or 2 amp on the standard circuits. So this basically, if you see here, you can see the rating for this particular CPU. This is basically HP computer's power supply, which is removed from its back of the cabinet. And if you see, you can read the ratings of this supply. It has an input of 220 to 240 volt, and it has a overvolt protection. And the output, you have 5 volt at around 16 amps and 3.3 volts at 16 amps again, and you have a 12 volt at a power rating of around 16 amps, which is a very excellent rating. And one single box providing 3 multiple outputs of 3.3 volts, 5 volts and 12 volts is really a boon. We can just straight away plug and play. But then the question is, it comes out with a bus like this, which one is what and what wire, how you convert that. For that there is a magic trick, like kind of a circuit board which is available ready in the market, which is this actually. So this is a conversion board available readily in the market, cost is about 200 rupees only. So the output cable of the SMPS can be connected to this one, and gives you that outputs immediately. So you can see these terminals here. This is an on off switch. These are the terminals. Here you get the 12 volt, 12 volt minus and 12 volt plus. We can make use of the 12 volt plus terminals, and this is the 5 volts terminal, and this is a 3.3 volts terminal. So you can just pull out all these points and then start using it to your layout. And for my layout, since I was keeping the design consideration of the table, especially I did not want the height of the table to go very high, beyond 4 inches, and that gave me a shortcoming of not able to install this box inside my layout. Otherwise I would have been very happy to put it. This, when I just kept it inside the box, the table here, this will not, the lid will not close, the layout will not close. So I have to do away with this solution. But nevertheless, I found another SMPS similar from the PC family only. There is one SMPS, it is called the Dell Optiplex CPU power box. That's also an SMPS, very powerful SMPS. The previous one had a 20 pin output. This one is having a 8 pin output like this, and this is the box, actually the SMPS box. This is much sleeker, height wise it is much lower also, and this has got a 8 port output. I just crypt the output plug so that I can show you the wire configuration. So this has got a output wire like this. The input power socket is just one single socket here, and it has got around 8 output lines. So in this, if you see here, you have multiple wires, 3 white wires and 3 black wires, and 1 blue wire and 1 red wire, and 1 copper wire which is left freely. So this is the output configuration wire. I was trying to figure out what was the output exactly that is coming. Initially I did not get any output directly when I connected, but then after doing some research, I found out that this blue wire was giving a supply voltage of 7.8 and the remaining was not giving any voltage. Then what I did is I short the ground wire, which is this copper wire here, to the blue wire. Basically this 7 volt is the switch voltage. When you just short it to the ground, then this all the rest of the wire starts functioning, and so all the 3 wires combined together was giving me a 12 volt output. And this 12 volt output is at the rating of around, we can see here, 12 volt is giving a rating of around 18 amps, which is much more than sufficient, or it's a overkill for this layout. So I have a 3 lead 12 volt supply, which can be further reduced to my required outputs, and nevertheless this is going to just give me one single socket power source, which I am going to just put it here and run an adapter so that one single cable connects to the board, to the table, sorry, and from that cable it connects to this source, and this source is going to give me this required power for the entire layout for various configurations. Now how do I convert this 12 volt into various requirements that we discussed? So let's talk about first 13.6 voltage. So for 13.6 voltage output, I will be using this XL6009 voltage booster board. This is just a very inexpensive board available easily in the market. When you just connect the 12 volt to the one end, the other end you can always get the desired output, whether it's 13 voltage or 14 voltage or 13.8 voltage like that, by just fine tuning this pot on this board. That's one module. And next is actually so the 13.6 voltage is required for the DCC, that is covered now. And next is for the Arduino and the sensor relay controls. We are going to be needing a USB 5 volt supply. So for this again we are going to use this module. This module takes an input of 12 to 25 volts variable input voltage and gives a very constant 5 volt output voltage at a rating of around 5 amps, which I can connect to the USB cable and then connect it to the controller to operate all the relays and other sensors and controls, and obviously to trigger the track switches also through a wireless module. And for the 3.3 voltage, I needed some 5 amp rating board which gives a constant power supply. So this is the board. Actually, I'll give the numbers of each of this board in the screen description. So this board basically takes in a voltage output from 12 to 24 and provides an output of constant 3.3 voltage output at a rating of around 2 amps. So this is more than sufficient to power my street lights, buildings, and all the other lights with accessory lights which is required for decorating the layout. So this is a third board that I'll be using, and obviously I'll be using a straight 12 volt also to power the motors for the car system. So that's about it. So instead of having that many power cards into the table, we are just going to be using this power box and these 3 modules to power the entire layout, which is further simplified and suits my design also to a larger extent by in terms of size and compactness. So this is the completed wiring structure. So there is some junction points created at the bottom of the layout to receive the wires from the turnout switches and from the motor, and also from the Loco Shed as well as the uncouplers. And these are the 2 bus receivers here and here, and they are interlinked to this bus receivers here, which are in turn connected to the microcontroller and the relays here. So this enables bus link enables the transmission of these connections from the microcontroller board to the layout board here actually. So I've just tried to keep the wiring minimum. So this is the connection DB25 bus. This is the Magno Car motor controller. These are the relays, and this is the important Wi-Fi module which is connected to its adapter. This is the screw terminal shield for the microcontroller. The microcontroller is just at the bottom, and from the power section there is just one single cable that is running to connect to the external power source, which is this wire basically. So only one plug is connected, and from this input of 220 AC is split into 2 sections here, one for the SMPS power input, and the other for the 12 volt AC transformer for operating the turnout switches, which is basically the coil motors. So from the SMPS the power is distributed through this distribution panels. So this unit is for 3.3 volt supply at 2 amps, and this unit is 5 volt for USB supply for the microcontroller, and the last one is for the train DCC controller power input. Okay, let us see how the architecture flow of the smart control panel works. The first component is the web-based application. This can be accessed via website address or an URL. So it is simply compatible to operate in a laptop, desktop, a tablet, or any smartphone device with a internet browser. It will take really another video to explain what is the software design and how this application interacts with the Arduino using another Arduino program. So that is a very long session. I probably thought I will make a video about that after completing my layout and completing this video series. For now, to focus on what this web app does is simply it has got a few touch points to activate the turnout switches and various other layout functions such as uncouplers, Loco Sheds, street lights, etc. When the user touches these hot points, the information as which switch is pressed and its position is sent to the ESP01 device. At stage 2, the ESP01 device receives the information from the web page. If we map the IP address of this ESP01 device, which literally acts like a web server, to a public IP, then this device can be accessed via internet. And this layout can also be controlled anywhere from the world, which is a silver lining. Now this ESP device, once it receives the switch activation information at stage 3, it communicates with the Arduino Mega board at the serial port and sends the data at stage 4. Now at this point, the data is processed by the Arduino program and identifies the respective relay connected to the respective port of the Arduino and sends the activation signal to the relay. The relay, once it receives the activation signal from the microcontroller, it acts as a switch and in turn controls the device which is connected to it at the other end, which is at the stage 6. Now the device can be any device. It can be a turnout switch in this case, or it can be an uncoupler, it can be a Loco Shed door, or any solenoid switch, or any light, or anything like that. So the entire layout control components are connected in the similar manner, and the entire circuit is formed like that. Now let us see how this thing functions. That's turned off. Okay, that is turned on. Similarly, you can also operate the switches here. So I press here on this switch, then another relay triggers over there, that will activate another switch. Another turnout here, I just press here, and then that indicates the track flow, and another relay opens up like that. And these are the siding switches. This also can be operated like this. And this is the main track switch. For every time I press, you see that one relay gets operated. And these are the uncouplers. So I press one of these uncouplers here, then that operates the uncoupler up in the layout also. I'll show it to you when the layout also operates actually, like that. Okay, so that was about the demonstration on the smart control layout system, where we were able to control all the switches, turnouts, and the Loco Shed doors, and also the slip switches on the car system. And in future, we are also going to control the rest of the uh, other switchable devices, like the station building lights and other residential building lights, like that. And also the smart control layout system is very versatile, and it's very easy to use. So we saw the advantages when we operated the layout itself. Now moving on to the next part of the video series, in the next I am planning to do the following things. First is, actually, if you see in the demonstration we saw just now, we were able to run only one loco at a time, because this entire layout is the track system is analog, and the locos are also analog. So at the max you can run one or two trains only in this layout. As mentioned in my very first discussion in the first series of the video, I was telling that we are going to convert this into a complete digital layout. So we are now going into that stage where it's time for us to install decoders into these small locos here. They are actually called the small footprint decoder. So this decoder is basically a low pilot decoder, which we will be installing in all the locos over here. So it is a very small footprint decoder. It is width is just about 10 mm by 6 mm, which is, if you can see from here itself in the video, that it is as small as a pencil head actually. So these decoders I have procured from US, and my friend Pradeep in US helped me to send this across to me. So I'll be installing those decoders, and we will also be controlling those trains using this NC power cab DCC, which I have discussed earlier in my videos also. So this controlling the trains using this this train controller with the pilot decoder on those small engines is going to be a very interesting part, which we will be doing in the next video. Next thing that we will be doing also in the layout is installing this small a semaphore signal, which I had procured for a very low price, and fixed it by fixing the coil motor, and then it seems to be working now, and I also fixed the lights. So we will install it in one position of the layout and see its functionality. Besides the standard semaphore layout from Marklin, I have also decided to make my own standalone signals, like the block signals like this. It's a very small signal. It's a 3D printed signal. I have installed the red and green light as an aspect for block signal. So we will also be installing these signals. So these are actually 3D printed, and they are as small as this actually. If you see here, there are quite a few here. It has a base as well as the head unit. So, these things will be put together to create one block signal like that. So we will be installing these signals also in the next video. And the next other interesting aspect is that we will also be installing the standard catenaries system for this layout. So this is the standard Marklin poles with the catenary strings. Now apart from this, I have also built my own catenary system. These are the 3D printed poles. So these poles will be used to install this these lines. Actually, these catenary lines are actually laser cut from a thin sheet of metal. It is completely made indigenously here in India, this pole and this catenary. So it will be interesting to see how it comes out after installing in the layout. Also we will be constructing some buildings actually. Like as I've said, this building is basically a 3D printed small train station. It's yet to be put together. So this will not have the grey roof as such. This is going to have this small brown roof. I'll be installing this as a small freight station, which is going to come here at this section of the layout. So this is also 3D printed. So we will put together and put that together with the lights and all, and see how that comes up. And from the 3D building perspective, I am also going to install the bridges on the sides for the guided turnout. So that also is already 3D printed. I'll be installing it. So this is what it is actually. So we will be installing it here somewhere here. 3D printing aspect. Also this is a signal house. The Toporama layout used to have a signal house, the Marklin signal house. This is a different one, not the same as that which is there in the Toporama layout. So this I'll be installing after painting it, and then adding some more decoration items to this 3D printed part. So this will be somewhere housed near the station, something like this. Of course, the street lights also will go together. So these are some of the small street lights that I have put together using the brass pipes, actually 3 mm brass pipes. I have made this all by myself using SMD LEDs. So we will be installing these LEDs right in the middle of the road system. So that will form the last decorative part. So thanks for watching. Keep watching out for the next set of videos. And as though this is a slow progress, I'm really happy the way the layout is all coming together. So let's see in the next video. Thank you so much.